Good afternoon. We're going to start Chapter 7. It is solving systems in Chapter 7, but 7.1 is going to be graphing. So we're going to be reviewing a little bit of what you worked with in Chapter 6 with graphing, and we're going to combine that with systems of equations. Here's the definition of a system of equations. It's two or more linear equations. Now we learned what linear equations were in Chapter 6. That's an equation y equals mx plus b is a linear equation. Ax plus by equals c is another linear equation. And then the point slope formula as well. So those are all linear equations. We're going to be dealing with two of them in Chapter 7, and that is called a system of linear equations. And we're going to solve that system of linear equations by graphing. And what we're looking for is a point. So we're looking for a point where the two lines will cross, and that is an ordered pair, and that will be the solution to a system of equations. A solution is an ordered pair, and we'll do an example here of what that is right now. So what we're going to do is we're going to solve this system of equations by graphing. So we have two equations, y equals 2x plus 1 and y equals 3x minus 1. So I'm going to flip to the next screen and graph it. Actually, let me just go ahead and use this one. We have an ordered pair, and we have 2x plus 1 and y equals 3x minus 1. I believe that's what the equation was. Yes, 3x minus 1. So the first one has a y-intercept of 1. So if you remember your graphing, we go to 1 on the y-intercept, and then we have 2 as the slope. So we write 2 over 1. So from here, from this 1, we go up 2, 1, 2, and to the right 1, and put a new dot. That's the slope. So we've gone up 2 and to the right 1. We just draw a line for that line now. So that line represents the line y equals 2x plus 1. Now we're going to do the same thing for the second line, y equals 3x minus 1. That has a y-intercept of negative 1. So we go to negative 1 and put a dot. So this is a new line, so we have to start a new y-intercept. The slope is 3 over 1. So from here, we're going to go up 3. So up 1, 2, 3, and over 1. And we get a line that is going to look like this. Okay, as clean as I can get with that line, we have that. That is our equation. So what we're looking for, let me straighten that line out just a little bit here. I'm going to take that line out just a little bit and move it over. Let me get an actual line here. And what I'm going to do is, it was through that line. There we go. So what we have here, here was the up 3 and over 1. There, had to stretch that out a little bit. So what we're looking for is where these two lines intersect. Well, it looks like these two will intersect right about in that spot. It's pretty close to that spot right there. So that has an ordered pair. So we say that the solution to that is going to be, it looks like we would have to go over 1, 2, maybe 3, and up 1, 2, 3, 4, 5, possibly 5. So that has an ordered pair 3, 5, approximately. So this is an approximate solution. As you can see, with graphing, it's going to be an approximate answer. So we're looking for where two lines intersect approximately. This would be the solution 3, 5, and that's approximate. So let's try another one and see what you can come up with for this. So let's try y equals 3x plus 2 and y equals 3x minus 2. And let's see what this one looks like. So what we're going to do is we have the first one having a y-intercept of 2 and the slope of 3. So that's going to be the red line over here. The second equation has the slope 3 and the y-intercept of negative 2. That'll be the blue line over here. Now, what I want you to notice is it doesn't look like these two lines are going to intersect. And you should recognize that they have the same slope. And as we defined in chapter 6, when two lines have the same slope, they're parallel. Well, from previous knowledge, either in middle school or last year if you had a pre-algebra or something, then you would have noticed that this would be parallel lines, and they do not intersect. So this has no solution. No solution when you have parallel lines. Now, from now on, you don't even have to graph these. Once you recognize that they have the same slope, you can automatically go to an answer of no solution. So you're going to recognize that quickly once you identify the slope. So let's try another one that we have to graph. We have two equations here, 3x plus 4y equals 12, and y equals negative 3/4 x plus 3. And with this one, notice that the equations are in two different forms. The first one is in standard form, and the second one is in y equals mx plus b, or slope-intercept form. So we're going to graph the second one by first identifying that the y-intercept is 3, and we can use our standard form to do that by making x 0. So x can be 0, and solve for y, we get y equals 3. Then what we can do is make y 0 and solve for x, and we get x is 4. So we get a y-intercept of 4 and an x-intercept of, excuse me, I misspoke, a y-intercept of 3 and an x-intercept of 4. There's your line for that first equation. The second equation can be graphed by doing a y-intercept of 3. Well, that was the same thing we had up above. And a slope of negative 3/4. So you go down 1, 2, 3, and to the right 4. 1, 2, 3, 4. Well, what do we notice about the second line? It's the same line. So I've now gone over 3 different situations. One where we had 2 lines that intersected at a point, another one that had 2 parallel lines, and a third example that had the same line. Well, this one is said to have many solutions. This has many solutions because the 2 lines are on top of each other. They will intersect in many or infinite. They use the word infinite solutions. So there's 3 examples of graphing where you're going to get 3 different answers. The first one, like I said, you get an ordered pair where 2 lines intersect. The second one, 2 parallel lines, no solution. And the third one, where you have the same line just written different ways, and that has many solutions. For your notes for you to bring to me tomorrow, I would like you to graph this equation, or these 2 equations, y equals 3x minus 6, and y equals negative, and that will be 1x, negative 1x. You can put a 1 right there. Negative 1x. I can't get it in there. I'm going to rewrite it. Negative 1x plus 2. Bring these 2 equations graphed tomorrow, and we will use this as your notes for the video.